Right, students. Now I will see. One. Is it visible, students? Is it visible?
Yes, sir.
Okay, now I'm going. I think last class we have missed here or here. This slide, I think so. Right? Is this class we have missed? Right? Isn't it? Okay. So generally students coming to the alternate wetting and drying, in alternate wetting and drying, especially students in summer or in very hot season, what will happen? Some minerals will be give some cracking. It will give some expand or contraction. What will happen? Some cracks will be happening. Here we can see some cracks will be happening in summer, and so come summer and during some binding. So in between two there will some binding nature also will be some binding material also will be there. This thing. So each mineral will be binded with some material. So any material, maybe organic material, some oxides, etc. During summer, what will happen? Some cracks will be formed in between the minerals. So this will happen in summer. In winter season, so in winter means dry, wetting season. What will happen? Some water will come here and it will join here. And due to the heavy drop in temperatures, what will happen? We can see some freezing. That freezing, what will happen? It will go and extend up to the end. The crack will be grows into down and down. What will happen? Naturally, our mineral will be breakdown. Breakdown means it will wither off, and it will become small pieces. This is one type of naturally happening weathering process today. So this is called the alternate wetting and drying. So during this alternate wetting, what will happen? Eventually they will lose, or even the strength of mineral will be lost due to the swelling and shrinking systems, all these things. Naturally we can see the swelling and shrinking problem in our this thing now in our black cotton soils, etc. We can see. And during the swelling and shrinking, there will be another mechanism will be taken with, that is called the pedoturbation. That is nothing but mixing. This contraction attraction. That's a different method we will discuss in the next class. Coming to the next slide, students, action of glaciers. Students, this we can see only in a very high where there is the icebergs, everything will be formed. Actually, in India, I think we can see in Uttarakhand and some Jammu and Kashmir, where the heavy snow is there is very iceberg glaciers are formed. We can see there. So what will happen means during the moment when this iceberg or when this frozen iceberg glaciers was moving, what will happen? It will carry over, it will pass over through the rocks. So when these ice glaciers were passes through the rocks, what will happen? It will extract, they will put tremendous pressure on the rock. They will put a tremendous pressure on the rock, and while moving these glaciers, they will take away the small pieces of the rock material also, and later on they will deposit in the lower area. And when the temperatures were raised up, what will happen? The glacier will be what will melt it off, the ice will melt off, and what will happen? Slowly the material which is was taken by the glaciers will be settled in that area. So this is one type of physical weathering, so action by the glaciers. So glacier will act upon, but it will show some tremendous pressure on the rock, and it will break the rocks into small pieces. This is one method. So another one is called wind, students. Wind we can see mostly in wind, mostly fine sand particles, clay particles will complete taken away, and you can see there is a airline material will be taken up so small, and wind some materials will be taken up. What will happen during this moment? Even you can sometimes even this word this type of thing we can see in erosion part also. That's quite different somewhat. So yeah, some wind particles will be carried, some aberration effect will be there while moving. Some rocks will be moving, small particles will go, and what will happen? This wind will be take away small particles and will deposit in the another area. This is one type. This is mostly this type of weathering, this type of action of wind we can see in deserts, especially in Thar Desert and or even Sahara deserts, especially some desert area you can see them. The shifting of the shifting of some these materials we can say. And sometimes this called as erosion problem. This leads to the erosion problem, and sometimes it creates a lot of problem barrel cultivated land. So what will happen when the action of wind was very high? The this well fertile soil was completely taken away and will be deposited in the other end of the portion. So this is leads to some other problem. And coming to the next, students, atmospheric electrical phenomena, especially this atmospheric electrical phenomena means you can see some big thunderstorms, big lightning. What will happen? It will break down the rocks. It will break down the rocks, and it like this, students. When there's a big, naturally you may not have chance to see this type of things. Very rare cases you can see this, wherever the thunderstorms or lightning is there, it will directly break down the rocks, small pieces. A big rock will broke down into small pieces. And mostly this atmosphere electrical phenomena. Only we can see in some electrical phenomena. You can say this type of conditions, students. And coming to the next, students, chemical weathering. Mostly, students, chemical weathering is completely given by chemical weathering started because of, it will physical weathering provides seed for the reaction of chemicals. Why? Because, students, I will ask one question. If we when will be the chemical reactions will be more in soil? When when any idea? Please, students, you should be very reactive. We have time limit in here, that's a problem. Any idea, students? When will be the chemical reaction is more, or in which particle the chemical reaction is more? In sand will be more, or silt will be more, or clay will be more? Where?
Clay, sir.
Clay.
Clay, sir.
Very good. Where two people have answered. Why? What is the reason?
More surface area, fine particles.
Yeah,
More
more surface.
surface area.
Yes, more surface area. This is what happening, students, because in physical weathering, the big rocks or big unweathered materials are completely were converted into small pieces because of different actions by water, wind, and some electrical phenomena, etc. So all those things will happen. So it will provide some set of reactions. So if it provides some set of reactions, so the small pieces provided some set of reaction, students. So what will happen after chemical weathering? In chemical weathering, there will be transformation of these small pieces. The chemical composition of that particular rocks will be completely transformed. We can see some transformation. We can see they will completely change in that transformation. So mostly this chemical weathering is mostly effective in small pieces only, small pieces, because small pieces will give some more surface area per volume. So per volume, the small fragments will give more more surface area, more. So this is what, students. So you can, and also 1 minute. And also, students, in chemical composition, this transformation of that original material of rock is completely depend upon the composition of the rock. Say for example, quartz response was very less, students. Quartz was very less because quartz is very highly resistant to the weathering. But at the same time, olivine and pyroxenes are easily weatherable because their composition is different. So based on composition and size of the fragments, all will place all are the major guiding factors for chemical weathering, students. And small pieces only will give small fragments will give more surface area for the reaction. So this ultimately leads to the formation of secondary products. Like we can see, mostly the secondary clay minerals, all these things are formed from chemical weathering only. So that part, mostly that term is called chemical transformation. So mostly chemical, that's called the chemical transformation. Okay, students, in next slide we will see very fast this reaction, student. What is the meaning of hydration, students? Any idea? What is the meaning of hydration?
Adding of water.
Adding of water, right? So if you add water, what will happen? What will happen? I think okay.
Expands.
Yes, it expands. Very good. I think SRF student, you should have more knowledge on this. You should have very depth knowledge on this hydration. Okay. Anyhow, so this chemical combined in particular substance may leads to a lot of structural changes, students. Why? Because whenever the H2O molecules were entered, definitely there will be some changes of structural changes. And due to this, as you said, there will be hydration and there will be swelling. There's increasing the volume. So this increase in volume, what will happen? There will be some disturbance in the structure, and the luster will become, that mineral will be very smooth and luster will become very soft. So ultimately, what will happen? In nature, all the secondary minerals, aluminum oxides, all will combine with water and form the so another mineral. So for best example, olivine, when it combined with H2O or combined with H2O, it will give another material called serpentine. This is what the chemical weathering, right? we get the another different product, that chemical transformation we can see. At the same time, hematite, when the water was added, what will happen? This hematite was converted into limonite. It is an yellow in color. Actually, this hematite will be in red in color, limonite will be in yellow in color. And bauxite, students, especially bauxite is a very huge mineral. Nowadays, it is highly available in few parts of Telangana and Andhra. Also, it is available as bauxite. Recently, they have identified very rich source of bauxite in some hilly areas. And when this bauxite combined with water, what will happen? Aluminium hydroxide. So another change we can see. Then so what will happen is it will is converted to oxides. So easily whether we can get the new product. At the same time, calcium sulfate. So anhydride calcium sulfate. This is anhydride. So when this was joined with what will happen? Joined with water molecule, addition, that is called hydration. What will happen? When water was added to the small particle, it will convert it into gypsum. So this is what the chemical weathering, students. So complete changes. The composition was completely transformed. Chemical transformation was happened here by changing their structure. The structure will be changed. The luster will be completely become very soft and common. When this is quite common process, especially we can see in secondary clay minerals. All these reactions are only in secondary clay minerals. These oxides, if you attend in the previous classes, we have discussed about the sheath layers. This is another type of secondary clay mineral. Secondary clay mineral. This is oxide form secondary clay mineral, students. So this is happens mostly. Hydration means nothing but addition of water molecule. Okay. And coming to the next, students, hydrolysis. What is hydrolysis, students? Any idea? What is the meaning of lysis? Hydrolysis.
Production of two compounds.
So dissociation of water.
Yes, there your seniority. She gave like a correct idea. Yes, there's a dissociation. There's a lysis means breakdown. Especially students, you see,
Yes, sir.
water molecule generally will go, it will break down into two ions. That is called H plus and OH minus ions, which can these ions will chemically combine with other minerals. What will happen? Other minerals sometimes it go to the exchange complex also, and it will what will happen in exchange complex and decompose the crystalline structure, and that leads to the formation of new compounds. And sometimes this water will act as a weak acid. Whenever it combined with any silicate material, it gives some different acid forms. So these acid forms will react on the rock minerals, that minerals which was broken by the physical method of weathering, and that will convert it into another form of mineral, students. This is what happening here. See, students, this orthoclase, potassium aluminum silicate, actually this is. So whenever whenever it was joined, H2O joined means some molecule will be there, some extra H plus ion will be added here. This is what happening here. So what will happen? Acid silicate clay was formed. Again, this compound, this will combine with another water molecule. So it will recombine with, ultimately end up with hydrated aluminum oxide. So see, there is a three water molecules. So and which results, which gives this silicate. This is a some acid or silicate acid will be formed. So this dissociation, this reaction. Sometimes if this reaction was very high in acid content, when the pH was very less, you can see this reaction is very quite common. So hydrolysis, lysis means breakdown, dissociation. Okay, this is a breakdown of water molecules, simple hydrolysis. So hydrolysis is nothing but H plus ions will contribute. H plus and OH minus also contribute to the reaction, students. So mostly the reaction is important because of two reasons, students. Why this dissociation was very important? Because you know this clay bases and silicate acids, substance formed in this reaction are available to the plant nutrients. Definitely, students, if when they definitely, as I said, there will be some exchange will be there, and also some dissociation will be, some minerals will be released. So this was very important for the availability of plant nutrients also, and also, students, and this water sometimes combined with CO2 and reacts with mineral directly. So what will happen? If water and CO2 was combined, what kind of acid you can get?
Carbonic acid.
Yes, it is a weak or strong acid. Is it weak or strong acid? Come on.
Weak acid.
Okay, finally, good. It's a weak acid. Okay, so water often combines with carbon dioxide and reacts with mineral directly. So that generally the carbonic acid will directly, what will happen? And in clay minerals and it will react with calcium, some cationic minerals and anionic minerals also, and soluble silica. All these ions, all whenever this reaction was happen, or this OH minus ions and carbonic, as you said, HCO3 is carbonic acid, and OH minus ions always this dissociated reaction is such an important, so it will release the plant nutrients. calcium, magnesium, sodium, all this will release, and that leads to the availability of our plant nutrients, students. This is the main reason why, because this H plus OH minus ions will always react with some clay minerals, and they will release the important plant nutrients for our crops, especially these minerals: calcium, magnesium, sodium, potassium, and even sometimes other anionic minerals also will be released by this hydrolysis reaction, students. So coming to the next, students, solution. Students, so some substance present in the rock, what will happen? Few substance will be there. What will happen? They're directly soluble. They will dissolve in the water. What will happen? And after dissolving, what will happen due to the excess water? The along what will they remove that solution, the dissolved solution will be removed, and during this formation, the solution formation, the rocks or the components will be end up with some holes and drills. You may see all these things. Best example, students, you see, suppose it is a big rock. Okay, some minerals are there. So for example, sodium, we have some sodium is a very good example. Sodium chloride is there. This is what I mentioned here, some halide. So water was combined. What will happen? It will dissolve. It will dissolve and dissolve. It will move away. It will move away from the rock. So ultimately, what will happen? You can see some small holes, big holes. Sometimes you can see big holes. So what will happen? Due to these holes, you will get up. You will end up with some holes, small holes. What will happen? The rock will be very weakened, and it will be broken down into small pieces. Okay. So like this, we can get some you can and this broken piece again will be interact with some other components, and again you can get some secondary compounds. So this is mainly happens, students, especially you can see sodium chloride. We can see mostly if you, yeah, this is what in reaction I have mentioned. Sodium chloride, when combined with water, what will happen? In water, generally the sodium will be dissociated into two ions. One cation is sodium, and ion is chloride. So like this we can see, so like this we can see two different components, and this will leaves this after the scorching effect, all these things, what will happen? It will leads to the small holes and rough area, and due to that heavy holes, that drills, what will happen? The rock will become very weak, and again it will wither into small pieces, and again it will convert it into another secondary compound, students. Another example, another form of is called carbonation, students. You know what is a carbonation? What is a carbonation, students? What is the meaning of carbonation?
Formation of carbonic acid.
Yes, it's a combine, especially whenever this this water and carbon dioxide combine, it will give some carbonic acid, and this carbonic acid will attack the rock and minerals, and after attack rock and mineral, what will happen? All those minerals, everything will be joined in this solution. Especially this carbonic acid major effect on some rock, especially limestone, students. Limestone has major effect. Limestone will easily attack this carbonic acid, and what will happen? This carbonic acid will remove the cementing agent. So cementing agent is nothing but your this thing now, many oxides or some organic compounds which withhold the mineral. So whenever you can see so this whenever this carbonic acid was attacked, what will happen? It will the cementing agent will be removed, and rock will be become small fragments, and it produced to the secondary mineral. Especially, students, see, this is a calcite, actually CaCO3. Whenever this was combined with the carbonic acid, what will happen? It become calcium bicarbonate, readily soluble. It is readily soluble. This is not soluble. Calcite cannot be soluble, but we can solve we can solve this calcium bicarbonate, students. So this is the major reason. So solution and carbonation. So you should know all these reactions. Okay. And coming to the next, students, oxidation. Oxidation is nothing but addition of oxygen. Okay. Addition of oxygen will be there. So whenever you add some oxygen was added, generally there will be some changes in the mineral, especially in ferrous oxide. Whenever an oxygen was added, what will happen? It will convert it into ferric oxide. We can say new component. So new component was produced. This is what the chemical recombination. That means we can say so chemical conversion we can see. At the same time, magnetite. Whenever magnetite was added to some oxide, it will convert into hematite. At the same time, hematite, again, this hematite was not sitting silently. If it is joined with some other water molecules, what will happen? Again, it will convert into limonite. Like this addition of oxidation reactions also, we can see lot of reactions, and leads to the formation of new components. New weathering will be happen. Especially oxidation is nothing but it is just addition of oxygen atoms. So this is what this is what in oxidation was saying. At the same time, At the same time, reduction. What is reduction saying? Reduction is saying that it is quite paka opposite to our oxidation reaction. Here the oxygen was removed, so addition of H plus ions will be taking place. So naturally, whenever this hematite was removed, what will happen again? Back to the ferrous oxide. So this ding dong battle between the reduction oxidation reactions, what will happen? You can see lot of functions, we can see lot of chemical transformation you can see, and these two reactions plays a major role in our availability of nutrients, and weathering process also will be affected, and ultimately how the soil was fertile was completely based on this redox potential. That you will read in chemistry, students. What is redox potential? All these things you will read in chemistry. So for here you learn all these things. Okay, this is what I explained in this paka opposite or oxidation reduction. Coming to the next, students, biological weathering. Biological weathering, very simple, students. How human beings are weather the soil? Our daily construction of dams, channels, buildings, etc. And animal, students, and human beings are like that. Animals means, best example, our rabbit, our burrowing animals, and annelids. Annelids means, what is that? Annelids means,
Worms.
I know, yeah, good. You should have some general knowledge also. So earthworms. So earthworms, everything, all components will release their. These termites also will go for some weathering process while the moving is there. It will contribute something to the something to the something to the weathering. And earthworms are really, they are called the friends for the farmer, students. Whenever the soil was enter into the alimentary canal, you can see a lot of physical chemical changes will be there, and it has a very high CEC, students. And if you read, there is a one famous, and that is called the vermicompost, students. There is a very famous article by written by one of the great scientists, Dr. A. Bhaskar. You please read that read that article, student, if you have time. It has very high CEC and very high fertility is there. You can see that's why nowadays farmers always encourage the growing the earthworms in their farm field, or at least they will use the vermicompost, all those things, because it will give very good physical and chemical changes in the soil. So like that. And also, students, some termites, all these things, how they will contribute? They, by their excretion, they will excrete some acids, or by doing some, whenever they're crawling, all those things, what will happen? They will contribute something. They will contribute to the weathering also by passing, whenever they're passing in between the rocks, or when they're going to the burrowing holes, all those things, they will contribute something. This is what regarding the animal, plant and animals. And higher plant, students, especially higher plants, they will join in between the crevices of the roots. Whenever the roots was penetrated in between the crevices, or when in the gaps between the rocks, what will happen? The rocks will break down and completely weathered. And also these rocks, especially this whenever the plant roots while respirating, they will release some CO2. That CO2 will will combine with water, and they produce carbonic acid, and that will give that, what will happen later on. And it will act upon the rocks and that minerals, and then will release some minerals, everything. That reaction will be happen. This is what is the plants. Plants plays its own role in our in weathering process. And also after death, I mean after the death of the plant and roots also, they will decompose. And even the death also will contribute something to the soil, this mother earth, this soil. So they will release some things, that they will release all the organic acids, everything. Those organic acids also will helpful for our production of soil, students. At the same time, microorganisms are very important source of our weathering process, students. Mostly you can see mosses, some micro plants like mosses, bacteria, fungi, actinomycetes. So everything will contribute something for our. They will release some. They will excrete some acids, and they will fix the atmospheric nitrogen, and they provide some seat of reaction for the plants. And after death also, even after death of their bodies also will contribute something. And when the plant remedies are there in the soil, whenever there's organic remedies, plant remedies or animal remedies, they will decompose and release some acids, some organic acids. That organic acids will contribute, we will decompose this our rocks and minerals, and produce the secondary another mineral, students. So this will like this, we can see some microorganisms also will place a major role in the production of our soil. So not production, weathering of soil. So there is a conversion. So microorganisms, they will give some seat of reaction for the chemical reactions, because they will give everything. They will give carbon dioxide, and they will give some organic acids, everything, the weak organic acids. So ultimately we can get something for weathering process, students. This is what regarding the microorganisms. So anyhow, after a great struggle, we are end up in this lecture, students. And thank you very much, especially though you are only three students. You're given lot of chance for me. Thank you. After a lot of delay, everything we are completing this. Anyhow, based on these lectures, we have a we have exam. I will say maybe tomorrow. Mostly, I will try to conduct exam tomorrow or, or day after tomorrow. And hereafter, every Wednesday, like this, from Wednesday to Saturday, 4 days we will have regular classes, and after those 4 days we will have one exam. Okay, hereafter there will be no problem, students. Even if you have some channel problem, we will conduct like this in our private channels. Okay, thank you, students. If you have any doubts, we can ask now. Any questions, students, regarding with this?
So, sir,
Yes.
sir, what is difference between consolidated and unconsolidated?
Consolidated. Think it's just no. How can I explain? Consolidated means it's joining something. Consolidated, some few materials will be joined. Unconsolidated means some materials will be, you know, it will be divided. It will be spread somewhere. While reading the sentence, you can understand that.
Sir, parent material is unconsolidated, sir, or consolidated?
Parent material is
Sir, parent material is example for consolidated or unconsolidated, sir?
parent material. I think it's consolidated. Is there anything?
Sir.
Even
Okay,
after
sir.
completing this class, I will give proper definition.
Okay, sir. Thank you, sir.
Okay, students, I'm running out of time. We will discuss in WhatsApp. And thank you very much, students. Thank you very much for your patience. Everything. Next class will be on soil formation. Yeah, factors of soil formations. Thank you very much, students. You can leave the channel. I will give you answer in WhatsApp. Yeah.